here's a quick introduction to the cross product, which is also known as the vector product. So here I've written down C, which is the vector that is the cross product of the vectors A and B. And I want to quickly remind you of the other way to multiply vectors, the dot or the scalar product. And if you remember working with that, the dot product, what it was really doing was finding parallel or anti-parallel components of the vectors to create the dot product. And the cross product is doing the same thing, but for perpendicular. So when you think cross product, think perpendicular components. So let me write that down quick. The cross product is to find perpendicular thing, and it does this in two ways. One, it multiplies the perpendicular components of the two vectors it's made of, and two, the cross product is always going to be itself perpendicular to both of these vectors. So it's perpendicular in two ways. So let's go ahead and look a little more closely at that. So first thing, it's the vector product. So C itself is a vector. So we can find the magnitude of that vector, C. And let's go ahead and do an example just so we've got something concrete to look at. So let's say our vectors that we're multiplying to get the cross product are going to be this one, that'll be A, and then B will look like this. Okay, and they'll have an angle in between them. We'll call it phi like that. So if we're getting the magnitude of the cross product, what that is going to be equal to is the magnitude of the vector A and the magnitude of the vector B and the sine of the angle between them. If you remember for the dot product, it was the cosine because that was doing the parallel pieces of the vector. Here it's the sine. And if we take a look at this and make maybe a little right triangle here for the vector B, well, this side of the right triangle here, that's going to be the magnitude of B times the sine of that vector because it's opposite this angle here. And this here, that is the perpendicular component of B when you're measuring from A. So in that way, that is one reason I'm saying the cross product is the perpendicular product of these vectors, because this piece, B, times the sine of the angle between the vectors A and B, this is the chunk of B which is perpendicular to A. So the cross product is finding those perpendicular pieces. Now, if you think back to geometry, you might recognize this as a formula for something else. It's the formula for the parallelogram. So this thing I'm drawing in red that has the sides A and B, this is the area of that parallelogram. So if that's something you're familiar with, these parallelograms, that being the area, that's another way you can think of the cross product. All right, so we've got the magnitude. Now let's find the direction. And one way to do this is what is called the right-hand rule. So let me write down how we do that. First thing, you got to do it with your right hand. So if you're right-handed, you're going to have to put your pen down and get your right hand ready. If you're left-handed, congratulations. This is one of the few times that we've set things up just for your benefit. So first thing you do, the fingers of your right hand are going to point in direction of the first vector. And then once you've done that, your fingers are going to curl towards the second vector. And once you've got that taken care of, then your thumb points in the direction of the cross product. So let's try this out for our example. So the fingers point in the direction of the first vector. So here, that's vector A, and vector A is pointing that way. So we'll take our right hand and we'll point our fingers so they're pointing in the direction of A. All right, got the first step. Next, we need to do the second step. We need to curl these fingers towards the second vector, and I can't like do it like this. I have to rotate my hand so they can curl from A like this to B like that. Let's quick write down what we did. So here, that's vector B, and vector V points like that. So my hand first goes in the direction of A, then my fingers curl towards B. And then if I extend my thumb out, it's coming out of the page towards U. So then that's telling me which direction the cross product is. So here, the cross product of A and B, that's C, and it's out of the page. And there's a way that we can write that. It's a dot with a circle around it. So here we could put a dot with a circle around it, and that would tell us that C is a vector coming out of the page towards you. And that's how you do the right-hand rule. And you can see here, this is out of the page. Out of the page is 90 degrees both to the vector A and to the vector B. So again, the cross product is perpendicular. It's taking the perpendicular components, and the cross product, the direction of it, is itself perpendicular. So that's the basics of what you're going to need for the cross product. The only other thing that I'm going to tell you as a just little aside, if you need to draw an arrow, if it's on the plane, you can of course draw the arrow like that. But if it comes out of the page, you draw it like this. So that's out of page. That's direction C is. But if we had done not A cross B, but instead B cross A, well, then let's go through our right-hand rules again. Point our fingers in the direction of B, and then rotate our hands so we can go from B and curl towards A. Our thumb would point down. So that would be into the page. We could write that like this. So an X with a circle around it, that would be into the page. And one way you can remember it is you can think of like an arrow, like not a vector arrow, but like an actual arrow that you'd shoot out of like a bow. So it's got a little arrowhead and little feathers. Here you can think of the arrow is flying towards you, and you're seeing the tip of the arrow flying out of the page at you. So that's the out of the page symbol. Here you've got the cross with the little feathers in the back. So you've got an X showing the two little feathers. The arrow's flying away to you, away from you, into the page. So that's just a way to remember these two symbols for into and out of the page. And that's almost everything you need to know about the cross product, but let's go take a look at a simulation just to get a little bit better idea. Got a little simulation here. You have the x-axis in red, the y-axis in green, and the z-axis in blue. And we have three vectors that are drawn on here. Vector A, so I'll wiggle that around just so you can see there's vector A. Vector B, there it is. And then this third vector here, which is responding to that. And that's because that third vector is the cross product, A crossed with B. It's a little faint here if you can't see it, but that's what it is. And you can see it's in the right direction. If we do our right-hand rule with A, that's along the x direction, and then curl our fingers so they point towards B, our thumb will point in the positive z direction, which is the direction that the cross product is in. And you can also see that A, it's only in x and it has a length 2, and B, it's only in y and it also has a length 2. Those two are perpendicular to each other, and that's what creates our cross product. And the magnitude of it, if I just rotate this so we're in the xy plane, you can see the magnitude of the cross product is the area of the parallelogram created by the vectors A and B. Here that parallelogram is a square, so let's just change B so we get a more parallelogram-y looking parallelogram. Area is still 4 here, magnitude of the vector is still 4, and the cross product, as you can see, is still pointed in the x direction because it is going to have to stay perpendicular to both A and B. So let's rotate back up again so you can see that cross product vector, and we can change things a little bit more. So remember, it's perpendicular, this cross product. So if I slowly rotate B so it is more and more parallel to A, When the two of them are perfectly parallel, they're both only in x, you can see we don't have a cross product anymore. It's equal to 0 because there's no perpendicular pieces. And I'll rotate it back this way, and you can see that we get the same magnitude, but now it's negative. And that makes sense, again, with our right-hand rule. Fingers pursed along A, and then they curl towards B, and our thumb will point down now in the negative Z direction. So feel free to play along with the simulation. You can just sort of change what happens and see what the cross product is. But one more thing that I wanted to show you is you can also pull A out of the plane like this, and you can see that cross product is remaining perpendicular to both A and B. As I move A up, the cross product tilts away so it stays at a right angle. The same thing will happen with B. So the cross product, remember, its theme is being perpendicular. It finds the perpendicular components of the two vectors that make it up, and it itself remains always perpendicular to the two vectors that create it. So one more thing that I want to talk about before we leave the cross product introduction, and that is why folks talk about our coordinate system as if it's a right-handed coordinate system. What they mean by that is if we have x here and our y direction this way, we necessarily then have to have z coming out of the board towards you. So I'll draw that as our little dot with a circle around it. That'll be z. That means out of the board or the page. Z is going out of the page here. And if we do that, then if we cross x, an x vector with a y vector, we'll get a z vector. Another way to write that is to use our unit vectors. So remember that we denote x pieces with an I hat, and we denote y pieces with a j hat, and z pieces with a k hat. So if we multiply these unit vectors, I hat crossed with j hat, got ahead of myself there, I'll get a positive k hat. Let's double check that using our right hand rule. So we take our right hand, we point our fingers first in the direction of I hat, or along the x-axis, and then we rotate our hands so we can curl our fingers so they point up into y. So they were pointing in x or I hat direction, and now they're curled up so they're pointing in y or the j hat direction. And if we extend our thumb, it's pointing up out of the page towards you, which is the direction of z, or the k hat vector. And we can actually cycle through alphabetically. So you notice we're going in alphabetical order here. I, j, and positive k. We can do j crossed with k, or y direction crossed with c direction. That is, we're going in the y direction, and then we curl our fingers so they point up in the z direction. Our thumb points in x, or the I direction. So that'll be positive I hat. And then k hat crossed with I hat is positive j hat. So again, kind of alphabetical, though you have to make the funny thing that when you get to k, you loop back to I. But as long as you're willing to do that, say that the order is I, j, k, back to I, when we go in alphabetical order, the result is always positive. And that's really what people mean by a right-handed coordinate system. The x piece crossed with the y piece gives you positive the z piece. If we go in reverse alphabetical order, or negative alphabetical order, so instead of I hat crossed with j hat, we do j hat crossed with I hat, well, let's see what happens. So j hat's y, so I'll point my fingers in y, and then when I cross them with x, I'm going to have to rotate my hand so that I can curl my finger to x. Then my thumb is pointing down, or in the negative z direction. So this would be negative k hat. So if you go in negative alphabetical order or reverse alphabetical order, you'll get the negative here. So that'll be true here as well. If we do, instead of j hat crossed with k hat, we do k hat crossed with j hat, we'll get negative I hat. And if we do I crossed with k, we'll get negative j. So just something for you to keep in mind when you're doing the various components, the x piece, the y piece, and the z piece. If they're in alphabetical order, you'll get a positive answer. If they're in reverse alphabetical order, you'll get a negative answer.